Welcome, viewers, to an extra special episode of It Depends today, because usually we have one guest. Today we have two of them. Justin Borgman, as you can see, he's the CEO and founder of Starburst, and Martin Traverso, who is one of the creators of one of the most popular open source analytical engine called Presto, while he was at Facebook. Today, he is also the CTO at Starburst. Interestingly, Starburst is purveyor of what we now call Trino, which is based on Presto, which was started in 2013. So it's a great honor for me to have the two of them be present to celebrate this landmark anniversary of Presto. So thank you so much for joining us.
Thank you for having us.
Thank you for having us.
Thank you. So, Justin, I saw you almost a month ago in Boston at your highly successful Data Nova conference, and it's always a pleasure. Can you please give us some background of how you ended up with Starburst and an introduction, please?
Sure. Yeah. So again, thanks for having me, Justin Borgman, co-founder and CEO of Starburst. For me, the journey in big data and analytics goes all the way back to early 2010 when I founded my first company, which was called Hadapt. And that was an early SQL engine for Hadoop. So back then, we were commercializing actually the research of my co-founder, which was called Hadoop DB. And it was thinking about, Hadoop as a data warehouse. And so in a lot of ways, this was some of the earliest thinking around data warehousing in a data lake. That business was acquired 4 years later by Teradata. I spent a few years at Teradata really thinking about the future of data warehousing. And while I was there, I met Martin and his co-creators who had recently developed Presto. And to me, what was so exciting about what they were working on was this idea that this was not just a SQL engine for Hadoop, which I already had a lot of experience, but this was a SQL engine for anything. And to me, that was a game changer, because even during my time at Teradata, who was the industry leader in data warehousing, not one of their customers actually had all of their data in Teradata. They all had data in data lakes and other database systems. And so you naturally had these data silo problems and this decentralization of data. And so to me, what Martin and his co-creators had developed was a potential solution that could stand the test of time, that could provide analytics across data wherever it lives. And that got me super excited. And so we decided to form Starburst as the company behind this. And yes, the name changed to Trino, and fortunately, Martin and Dane and David and the others joined us, and the rest is history, as they say.
Very nice. And Martin, how about yourself? How has your journey been?
So I started with getting involved in big data analytics back when I used to work at a company called Ning. It's a social networking company from between 2005 and 2009. I was there, and I was one of the people that introduced Hadoop into the company as a way to do analytics. So that's how I started getting involved in that space. Then I ended up leaving that company. There's a lot of stuff I learned during my time there in terms of how do you build large-scale systems that have to support thousands of users running on thousands of machines. So I ended up leaving. Eventually, I made my way into Facebook. I joined at the same time as Dane and David, who are the two of the other co-creators of Presto, and we joined the data infrastructure team at Facebook. And we were basically trying to see, okay, what are the problems? What are the big problems we have to solve here? And at the time, Facebook was predominantly using Hive as their analytics tool of choice. Mm-hmm. And I don't know if you're familiar with Hive, but it tends to be, it's very powerful. It was very powerful at the time. You can run massive queries on thousands of machines, but it was very slow. And people were using that for interactive analysis and Facebook was a company that prided itself in being data driven. So that tool was getting in the way of people doing their job. There was a famous internally famous quote when we're at Facebook from one of the data engineers or data scientists, where he said, "It is a good day when I can run 6 Hive queries," which is pretty crazy. I mean, if your job is to look at data day in, day out, do analytics, try to get insights out of data, if you can only run 6 queries, then you're not going to be very effective at your job. So we looked at that problem and we said, okay, well, we can do better here. And so we set out to build Presto as a tool to be able to interactive analytics over the massive warehouse that Facebook had. At the time, it was about 300 petabytes of stored data, and we had thousands of users using it every day. So that was the big challenge. And then we said, well, from the beginning, we want to make Presto open source. We want it to be available to the larger industry. We believe software would get better if it got more exposure, if other people got a chance to use it, to provide feedback, and even to contribute. So from the beginning, we set it out to be an open source project, and that it grew faster and bigger than we ever thought it would be possible, and it got other people involved. I mean, Justin and his team was one of them, and then as Justin said, the rest was history.
So Martin, staying with you for a minute. So Justin just said that one thing that attracted him about Presto was that it wasn't just a SQL engine. It could do any query on any big data storage. But even then, when you started way back, at that time, most deployments, I'm presuming, were on premises. I believe Facebook still is on premises. So how did you come up with this design that is now applicable to this modern cloud native architectures?
Right. So there was a bit of, I guess, serendipity and kind of accidental. I mean, we came to it in kind of accidentally, but also as a forcing function based on what we were trying to do at the time. I mean, we didn't set out to make it have the architecture that it has for any particular reason, other than we had 2 goals. We wanted Presto to be able to run against Facebook's internal systems. Facebook was running a fork of HDFS at the time. It was running a fork of Hive, a fork of the Metastore. So it was different software from what everyone else in the open source world or the larger community had access to. And we also wanted those people to be able to use it. So when faced with that question, we said, okay, how do we satisfy both? And we kind of stumbled upon, okay, well, we need to create an abstraction layer for the metadata and the storage and how the tables are presented to the Presto engine. And that's when we introduced this concept of plugins. And that forced us to make the interface pretty clear in terms of how all the data is exposed and visible to the engine in the forms of tables with columns and data types. And then we ended up providing one plugin for Hive for Facebook, one plugin for open source. And then very quickly after, we had other cases where people were saying, well, to give you an example, it was a team at Facebook. We had a friend there. He was working on the backend for the newsfeed, right? And they wanted to do analytics over that data. It was a custom data store in memory across multiple machines. And they were embarking on a project to implement a query engine on top of it. So we said, hey, stop. We have Presto. You can plug in a different storage layer, different access layer. And we said, we'll teach you how to do it. Within 2 weeks, he had a prototype running, and within another 2 weeks, he had it deployed to production. So in a month, he had a full SQL query engine running on a custom data store. So that was like eye-opening. It's like at the time we said, well, this is bigger than we thought. Like we can support a bunch of other use cases that we cannot support, that we didn't think we could support. And then that just over time became the natural transition. Okay, well, if you're running on-premise against HDFS and the Hive Metastore, you can use a certain set of plugins, but you can also deploy it in a cloud environment with different backends, with object storage, with I know the metadata layers offered by cloud providers, or potentially other data stores. You can connect it against MySQL, Postgres, Kafka, Redis, whatever data store you can think of, as long as you can expose that data in terms of tables and columns and rows.
That is fascinating, how this accidental need to separate compute and store because of Facebook having forked off its own stuff led to what we use today. So Justin, so I'm curious. So now I see why you got so attracted to Presto, but now you have Trino. So what happened in that journey between Presto to Trino?
What happened? Well, yeah. So when we first started working together, it was still PrestoDB. When Martin, Dane, and David decided to leave Facebook, they continued development on a new branch, which was called Presto SQL. And so for a brief period there were really two Prestos. There was PrestoDB and Presto SQL. And, a lot of the market didn't know, Presto was Presto and didn't necessarily know the difference or what was going on there. But PrestoDB was the continuation of Facebook's efforts, whereas Presto SQL was the community development. The rest of the community, including Starburst, followed Martin, Dane, and David as the creators and continued to invest there. Along the way, there became a trademark issue where there could only be one Presto, and so Presto SQL had to change its name, and Trino was born. But Trino is very much the legacy of Presto. It is, that same original code base that has now been enhanced and rapidly evolved over the several years since Martin, Dane, and David left Facebook, which I guess has been, I'm losing track of time, Martin. Now, are we 3 or 4 years now since you left?
It was end of 2018. So
yeah. Oh, okay. Almost 5 years. See, time flies when you're having fun.
Yes.
Yeah.
So Justin, just to dig a bit deeper, is this trademark issue of Presto, is this when Linux Foundation came into the picture?
Yeah. So, the way that sort of trademark law works, IP that is created while you're employed by a company. So in this case, Martin, Dane, and David created Presto, but they created it as Facebook employees. Facebook therefore owned the trademark and later decided to contribute that trademark to the Linux Foundation. And the Linux Foundation, felt the need to, enforce their trademark and hence the need to change the name.
Got it. All right. So now we're going to change tracks a bit because Presto and Trino have been very successful as technologies. But some years ago, I saw Starburst put a lot of weight behind this new concept that Jean-Marc Degani had come up in 2018 called data mesh. In fact, I have my book, just ironically, it's compliments.
Yeah, there we are.
Starburst. So belated thank you. So this is my Bible here. I am literally deep into one of the 4 principles called data products. And just today I finished writing a new paper on that. But I'm curious, what attracted you to data mesh, and what is the traction behind the 4 principles, especially data products?
Yeah, and I'll make a quick plug, maybe get Jean-Marc a few more copies distributed. You can find that book actually for free on our website. If you go to starburstdata.com, we offer free digital copies of it. So yeah, to answer your question, to me, what Martin and team had created was a revolution of sorts in terms of how you think about executing data warehousing queries. And it was turning the model inside out, which was what drew me into it and got me so excited about it. And it was what, was drawing many of our early adopter customers to become, Starburst customers. However, it didn't really have a name. There really wasn't a label or a paradigm to describe what this allowed you to do. until we discovered data mesh. And not to say that Starburst and data mesh are the same thing. We don't sell a data mesh per se, but we certainly help enable it, because another one of the pillars is a self-service platform, essentially, that allows you to work within a decentralized environment. And I think that's the core element that data mesh spoke to, was that data is decentralized naturally, organically, almost as a just a natural aspect of the universe. It's like entropy in the universe that just has to be decentralized for so many different reasons, different purpose-built data sources, new databases coming about every day, many of which end up on this show with you. You've got data lakes, data warehouses, different departments, you buy companies, that creates decentralization. And so data mesh was basically saying, you know what, decentralization isn't a weakness, it can actually be turned into a strength. And to me, that's what got us very excited. And yes, data products, I think, is maybe one of the most exciting and easily applicable elements of the data mesh concept, which is to say you can curate high quality data sets, essentially, and publish them as a product to others within your organization, or maybe even external outside of your organization. And this now enables more of that self-service consumption, because I, as a business analyst, data scientist, or even software developer, can go into this sort of marketplace of products and find the product that I'm looking for, rather than having to dig and dive through tables and rows and columns in a variety of different systems. So this is a level of abstraction that I think enables greater consumption, and it's something that I'm equally excited about.
So Justin, I'm going to ask you for some examples of data products and what you're seeing from a practical point of view. I love what you said. Instead of throwing a table over the fence and saying, have at it, you were taking a more product-like approach. So I love that. I'd love to hear some examples. And when you're done, Martin, I'm going to ask you, how do you see, because you come from a different angle, which is more technology, what does a data product mean to you? So, but before we go to you, Martin, back to you, Justin. Give us some practical examples and an idea about the adoption of data products today and what you see over the next few years.
Sure. So, a data product can be anything from, a specific table in a database to the result of a join between multiple tables and multiple databases. And so there's a lot of flexibility on, what that data product represents. But I think the key is attaching to it business value, business context around why that product is important. So, maybe it is how the weather impacts crop yields, and you have crop yield data from one system and you have weather data from another system, and we're pulling it together to create a correlation and a relationship between, weather and crop yields, as an example. It could be something from our billing database and people interacting on the websites and weblog data. And again, the combination of that, pulling that together in a consumable product for maybe my marketing team to be able to consume. So that's kind of how you can see it in practice. And I think at least when you're using Starburst behind the scenes, you get that level of abstraction above where the data lives. Like the consumer doesn't need to know anymore. I'm just looking for crop yields, by weather, and I don't need to know, which systems that is. I don't even need to know necessarily what Oracle or Teradata or Snowflake even are. I'm just really focused on, the business context.
And business people should not. They should
exactly.
not. Yeah. Why should they care where this data is, as long as they have some sort of a guarantee that this data is high quality. And so Martin, over to you. What's a data product for you?
Well, I'll say everything that Justin said. I couldn't have said it better. So, no. So to give you maybe a kind of a, what we saw at Facebook when we were at Facebook, we had a warehouse, I guess, at 300 petabytes. But I remember there were like more than 100,000, 200,000 tables in it. And this is, everyone had access to the warehouse. Everyone could go and write a query and produce a new table. And then you could just go and see what all the tables that were out there. and use them, and people would use them indiscriminately, and there was no clarity on what the tables are, what data they will derive from, what they include, what they exclude, what the fields mean, what the columns mean, how should I use that table? Should I even use it? Because sometimes it was tables that were created for a throwaway experiment, and people, oh, I find this table has an interesting name, I'm going to use it in my downstream processes. So data products, I mean, the way I see this is a way of, as Justin was saying, have an abstraction layer where you can organize all that data and package it in a way that makes it clear and usable and predictable for downstream business users. So we had some curated data sets at Facebook. For example, we had a whole team that built pipelines that would process video data and messages and user data, and then create these I guess today you could call it data products that said for every user, when were they last active, how many actions have they performed in so much time, and then you could get a kind of a it was a base product you could then go and join and use for different analysis purpose you might want to have for different downstream business use cases. So having that ability to organize your data, document it, provide examples how to use it, have the guarantees of how fresh it is, and be able to communicate that, whether it's freshness, correctness, etc. It's what these data products enable. I think the thing with Trino is that because we allow you to run queries and potential queries that connect multiple data sources in the same query, it kind of it gives it a lot more power than just thinking about one data warehouse where you're just packaging your tables in this way or that way. Because now you can bring in data from different sources, as Justin was saying. You may have, I don't know, dimensional data in an Oracle database, and you want to link it with your visit data, and you want to package that data in a form that is consumable. Well, before you had to do complex ETL processes to get all the dimensional data into your warehouse. You had to make sure that those processes are always running, that they are not lagging behind, or you end up having to explain how that lag affects the correctness of the data and so on. Now with Trino, you can build all these joins and processes in one place. You don't have to go and resort to all these complex ETL processes.
So basically, data virtualization behind the scenes. You're doing data virtualization. Do you still use that term, data virtualization?
So sometimes, it's funny. I have a particular slide deck where I say, is this data virtualization? And I say kind of, but not really. And what I mean by that is the term has obviously been around for quite some time. There were early players in that space, Composite, Denodo, and so forth. But part of what makes Trino so unique and Starburst so unique is we are doing that execution in parallel. We take huge advantage of parallelism to actually do that execution, join those tables in memory. And so the net result is you get performance and scale that data virtualization never delivered on. So some people have negative connotations with the word data virtualization, but we're sort of delivering on the promise of it maybe from 10 or 15 years ago.
I see. And then with some caching and columnar formats and some of those enhancements, vectorization, you get more performance benefits?
Those certainly all add to it. Absolutely. I mean, the execution engine itself is blazingly fast, but yes, you can add even more speed with our smart caching, our smart indexing capabilities, view materialization. And yes, when you're working out of a data lake, taking advantage of columnar data formats, especially some of these newer ones like Iceberg, which are great. So absolutely.
So one thing I really found interesting, what you said, Justin, was the self-service platform or the data infrastructure lies in this concept of decentralized domain-driven data product development. Who are your buyers? Are these do they tend to be centralized teams, or are these decentralized teams? And are they business or IT?
Well, it is very much both, and we try to make it intentionally both. And what I mean by that is the central teams generally are the ones running the infrastructure, responsible for the infrastructure. And very often they're the ones that kind of get it almost instantly. I would say a lot of enterprise architects, data architects that sort of see the benefits of this, modular design and decoupling storage and compute and the flexibility and what that can mean for them across their organization. So we love those folks, but we do try to connect the dots with the lines of business and the data consumers who generally have the business problems, the business use cases to be solved. And so we call it the hub and spoke model in terms of how we try to go to market and engage both parties. And I think things like data products are a great example of value that both sides, I think, can benefit from, where the data consumers, the lines of business, are able to find what they're looking for and consume it in a self-service fashion, while the central teams can still ensure the quality and governance and access controls are enforced. Our product includes very fine-grained access controls, row level, column level, data masking, and so forth. And so if you're trying to create self-service infrastructure that is connecting to multiple data sources, that becomes even more important. And the central teams can still have some ownership and control over that. So it's, like your podcast is called, it depends, and it's both.
Okay, great. Great answer. I don't want to put you on the spot, but what percentage of your customers today are already adopting the notion of data products? And do you see that changing?
Well, yeah, I would say, the early adopters are still, a smaller group. Today, I believe we have over 50 customers that are actively using our data products capability.
Okay.
And we have a few hundred customers in total. So, maybe it's 10% of our customer base is using the data products functionality today. But I think given the newness of data mesh and data products and a lot of these concepts, we feel really encouraged by that, that there are 50 large enterprises already taking advantage of data products. And so we see that number increasing over time. Certainly in our customer conversations, we see a lot of enthusiasm around that. A lot of companies have been looking for, cataloging solutions, other metadata solutions. They're trying to figure out this problem. And this is maybe a new approach that helps take them an extra mile in the direction they're trying to go.
Very interesting. So talking about a new approach, so Martin, I have a question for you. We have also seen last year and then this year, there's been a lot of movement on a lakehouse concept. Mm-hmm. So Apache Iceberg, Hoodie, and Delta have risen to be the new table formats for on top of data lakes. What is the connection between Trino or the work you're doing and these lakehouses? Table formats?
Yeah, so like I said, Trino is of course a plugin architecture. So you can plug in any implementation of storage engine you want. You could have a connector for Hive, basically understands the Hive table format and operates against that. You can have a connector that operates against DBMS, against a stream, like a Kafka stream or something like that. Or you can have a connector that operates against Delta Lake, Iceberg, Hoodie, etc. What those formats bring, and it's actually, I would say it's I'm very happy those formats came along. The problems we had to deal with when dealing with the Hive table formats back in the day, they make a lot of things so much more complicated. And what those formats, the new formats, bring to the table are a certain set of primitives that allow you to do things like, for example, updating data, deleting data in a safe and efficient way. Like with Hive, you couldn't do that. If you wanted to delete a row from a table, you had to rewrite the whole table. If you had two people writing to the table at the same time, you got the result is completely non-deterministic. You may end up with a mix of the two results in the output table. So the transactionality, the correctness of the result is super important. And these are all features that anyone that has used a traditional data warehouse is used to using, like ACID transactions, consistency, concurrency, etc. And being able to apply all those concepts from a data warehouse to the data lake is what these storage engines allow you to.
So I'm curious. You're right. All these table formats have introduced so many amazing capabilities. This whole update, delete capability on Parquet files, for instance, time travel. Is Trino taking advantage of those? When I think of Trino, before that Presto, I think of it as really fast query engine. But now that you can do these updates very easily, is this something you can do, like from Trino? Can an end user say, I'm mostly doing queries, but I need to update my profile, my address has changed. So how does that work?
Yeah, so that's a common misconception about Presto and Trino, that it's only a query engine. For the longest time, I think since maybe 2013 or so, we've supported writing tables in Presto, and so you can run a query, but the output can be another table, so you don't need to just present results to the user. And then after a couple of years, we added support for delete and for updates. For updates that are more recent, but you can issue inserts, deletes, updates, selects, like any transactional database. But it used to be that some connectors couldn't support those functions, and some connectors were very inefficient at doing those functions. So now with these new data formats, you can get that functionality much faster and safer. So because, for example, you can do, when you do a delete, it's an incremental operation on top of the table as opposed to rewrite the whole table. That can be done faster, and it's also because you have transactionality, you can do those deletes or updates, knowing that the result is going to be consistent. You're not going to step over other people's toes if they're doing the same thing at the same time.
So I now feel like geeking it out a bit. So I love what you just said. So the transactional and the analytical piece, we've been trying to bring those together for the longest time. So what Gartner calls HTAP, hybrid transactional analytical processing. I think the next realm is to also bring predictive into the same engine. Because today what happens is that if I want to run reports and dashboards, then I go to the BI reports or dashboards. But then if somebody says, well, I want to do some prediction, even simple thing like regression, then you go to a data scientist. Do you see that further melding of predictive advanced analytics happening in Trino?
I can certainly see that. I mean, back in 2015, so the beauty about the plugins in Trino is that normally you can provide connectors for data sources, but you can also provide custom functions. And so you can implement extensions to the function library by creating new plugins, right? So we had someone that implemented a plugin for adding some machine learning functions, and these were classifiers and also some form of regression and predictors, where you could say, you have a data set, you can do apply SVMs or logistic regression and so on. And certainly, like, it's just a matter of adding those capabilities as functions and to be able to enable those use cases. Recently, we added a feature called polymorphic table functions to the engine. And if you're familiar with some of the more powerful databases, there's this feature that allows you to effectively execute a function over a whole table, and the output is another table. So this is the perfect case when you're trying to do things like classification or linear regression, where you have to be able to see the whole data set, do some computation, and then annotate every row or partition and split the rows into different sets and so on. So with this core capability, now you can go and implement those functions. So now it's just a matter of having someone going and implementing the function. But then you can do all that type of processing within the engine directly. You don't have to export your data and put it somewhere else before you can do that.
This is great. So we're busting a lot of myths here. So Justin, I know you like to do myth busters, so here, this is my version, geeky version. So you can do machine learning through functions, you can do updates. So going to connectors, Justin, I'm curious, what is Starburst's strategy to support this ever-growing vast number of SaaS products that just keep sprouting up? I was just reading a while back that even a small company now has over 100 SaaS tools. Large companies have close to 500. So they all have their own silos of data. What is Starburst's strategy to extract that data for analytics purpose?
Yeah, in fact, I should probably ask our CFO how many SaaS tools we have, because it feels like it's in that 100+ territory ourselves. So I can empathize with companies out there that struggle with this. And yeah, each one offers potentially valuable, gold to be harvested in understanding your business more holistically. Our strategy is maybe twofold, I would say. First of all, there are the connectors that we provide. Some of those are built by Starburst, some of those are built by other members of the community. And because it's an open source project, really anybody can create a connector. And so you end up with a really interesting long tail of connectors that people build for their purpose, their specific purposes. But we, at least as a company, have had a particular focus more recently on SaaS connectors, to your point. So we have a Salesforce connector, for example. That turns out to be one of the more popular connectors in our portfolio of connectors, because pretty much every company has valuable data in their CRM that they want to include in their analysis. So that's one element of the strategy, is building out our own direct connectors so that you can query that data, you can do transformations on that data, you can materialize that data however you'd like. The other element is, despite the fact that we make ETL optional, we're also totally cool with times where you do want to do ETL, right? And there are going to be cases where it makes sense to pull data out of those systems, consolidate it maybe in a data lake where we think you're always going to get the most bang for your buck, if you will, and query it and incorporate it there. So we do work with partners like Airbyte, for example, which has a long list of connectors. Fivetran recently started supporting ETL into a data lake. That's a newer development on their front. So there are a whole host of options to kind of dump that data into a data lake now. And that's the second piece of the strategy.
And can this data be structured, obviously semi-structured and unstructured?
Yeah, and certainly Martin knows this better than I do, but we support so many different types of file formats. I mean, JSON, XML, CSV, of course, the open data formats that people are most familiar with, Parquet, ORC file, Avro, Iceberg, Delta, Hootie, like basically everything under the sun.
That is amazing. Martin, how is Trino deployed? Is it a container using Kubernetes? Is it an agent or SaaS product? What are the different deployment options?
Yeah, so Trino itself is just a downloadable software. So it's a tarball, basically. You download a tarball and you unpack it and you run it. And then it's up to whoever is running it to decide how they're going to deploy it. I mean, we also provide a Docker image, so to make it easier for people that are using that in their environments. But like anyone running on premise will typically either use a custom system for deploying software, like out of a tarball, out of Docker images, or they will use Kubernetes. That seems to be a more popular option these days. And then if you are running, for example, in the case of Galaxy Starburst, you actually don't have to care about deployment. You just sign up and use the platform without having to worry about how the software is deploying clusters, how it's upgraded, how it's managed, monitored, etc. We take care of all that for you. So under the covers, we use combination of custom systems, Kubernetes, Docker images, multiple data centers. We have a layer that allows us to do upgrades without downtime, like green blue deployment type of thing, and so on. But it's really like it's all over the place. Depends on the organization.
So in case of Galaxy, which is your SaaS cloud-based offering, is Trino running in your VPC, your account, or can clients run it in their account? How does the security piece come in the picture?
Right. Yeah. In the case of Galaxy, Trino runs in our infrastructure.
Okay.
And then customers provide when they want to set up a cluster, they provide a connection into their data source. They provide the access credentials and so on. And then at the time when a query runs, Trino goes and fetches that data through that secure connection that they set up, does the processing, and then produces the results either back into a data store that they configured or via the UI or client that they are connecting with.
So, I'm curious between Martin and Justin. Dave Vellante has this whole idea at SiliconANGLE, the cube or super cloud, where you are abstracting hybrid multi-cloud. Do you have clients that are connecting to sources in different cloud providers on premises and abstracting that? Like, how does a hybrid multi-cloud get addressed?
Yeah, very much. I mean, a lot of our customer base is large enterprise, and large enterprise tends to be multinational and multi-cloud. And in many cases, and I would say increasingly so, intentionally multi-cloud. I think some of the big banks have gone on record publicly as saying they will be multi-cloud. And I think I've heard Jamie Dimon at JPMC say, 4 clouds, meaning the fourth being their own, right, on-prem. And so I think this is absolutely here to stay. And it happens to be one of the areas where we excel by virtue of being able to connect to data in multiple places. And we actually built a special connector specifically for this purpose. We call it Stargate. You can tell we have a lot of fun naming things here at Starburst. Our caching is called Warp Speed. This special connector is Stargate. And it's essentially a connector between Starburst clusters. So you could actually have one on-prem, one in the cloud, maybe one in AWS, one in Azure. And these clusters can speak to each other and push the processing to where that data physically lives. And so this allows you to minimize egress, which is one of the biggest barriers to, I think, what Dave Vellante is, envisioning there around the super cloud concept is, they charge you like a toll booth every time you move a bit or byte from one cloud to the other. And so if you can minimize that, then this vision becomes much more of a reality. And I think for large global multinationals, this will be a necessity in the near future.
Yeah, very nice. I have a question for you, Justin, about some of your biggest deployments. I'm just curious how big they are. And a question for Martin about this fun names that you mentioned. So let's start with you, Martin. Where did this name Trino come from?
Oh, well, this goes back to what Justin was talking about when that whole trademark discussion happened. We were basically forced to come up with a name very quickly. And we had been thinking about some names, but it's really hard to name things. It's like you have to find a name that is memorable, easy to pronounce, easy to market and promote on the internet. Like any common word is going to be impossible for people to find. So we were talking with a bunch of names, and eventually, like in that week where we're rushing to change the name, one of the names that came up was neutrino. It's a particle. It's super fast, very light. It kind of reflects the character and the nature of Trino as we saw it. And then I had the idea of, well, that's going to be hard to, again, market and so on. So I said, why don't we shorten it to Trino? And then the other ones they were in the discussion liked it. We checked whether the domain name was available. We did a bunch of Google searches to see how many things came up, and there was not a whole lot. So we said, okay, this is a perfect name.
Very nice. So that was your creation. Trino was your idea?
Well, I mean, it was a collaborative idea, and then I ended up coming up with the final
Very nice.
idea to shorten it.
I'll add another piece of trivia, maybe for your audience, Sanjeev. The bunny mascot for Trino has a name, and that was named by the daughter of actually our head of engineering here at Starburst, and she named it Commander Bun Bun, and we had a contest, and Commander Bun Bun was the winner. So the Trino bunny is Commander Bun Bun. Okay,
Yeah,
so
we opened it up to the community, and a
Yeah.
bunch of people suggested names, and his daughter suggested that name, and everyone loved it, and that was a clear winner.
Dun, bun, bun. There you
Yeah.
go. Yes.
Yeah.
Trivia for the day. Thank you. So Justin, back to the more mundane topic. What is the biggest deployment in terms of number of nodes or volume of data that's consumed or query scanned?
Well, it's certainly measured in thousands of machines and hundreds of petabytes of data, because the largest customers, interestingly, generally don't have one monolithic cluster. They generally have multiple clusters. And Starburst and Trino lend themselves very well to having multiple clusters because you don't store the data. So you can actually point, the same compute memory resource to the same, or different, compute memory, clusters, if you will, to the same storage. Maybe it's object storage or what have you. And so we see our more advanced hyperscale customers deploy multiple clusters for maybe different departments or different use cases. They may have a long-running batch cluster. They may have a short-running interactive cluster. They may have one for the executive team that needs their dashboards to be running all the time. They may have one for the product team. And you can really create really nice resource isolation that way. But in aggregate, in those larger customers, it's thousands of machines. And, this is part of what's made this company particularly fun to build, is that we started in reverse. Like, we started with what Martin and Dane and David had done at Facebook, which had to run at scale from the first moment you ever ran a query, right? Like, that was the table stakes, was run at ridiculous Facebook scale. And so we got to skip those parts of company building where people question whether this stuff works. Like, normally that's what you deal with. My first startup, that was common, can this really work at scale?
Yeah.
But with Starburst, we've sort of, gotten to leapfrog ahead because scale was, a prerequisite. And so we've got some really exciting, very large, customers and public users as well.
Can you name some of the large ones and where are they running?
Yeah, so I always have to be careful of which logos I'm allowed to speak about, but Comcast, DoorDash, I know those are some of our public references. Within the open source community, folks like LinkedIn and Lyft, are huge users. So some really big names out there.
Are there any use cases that caught you by surprise and you weren't expecting and now you see them?
I'll say for me, and maybe Martin has one on this. For me, I've had a few surprises, but one of the ones that's really turned into like a repeatable motion for us is the desire to run batch transformation jobs. Like, Trino was known as an interactive engine. It was known for fast running short queries that were interactive for ad hoc SQL or BI use cases. And customers were like, oh, this is so awesome. It's so fast. I'm going to run it on like the really big stuff and make that go faster too. And we're like, wait, I don't know about that, and they would deploy it, running on multi-hour, jobs. And that led us to really harden long-running queries and build this fault-tolerant query execution into the engine, which means it can now support the longest jobs imaginable, and the query will never quit. It'll just keep going and keep going. And so that's very much like a customer and user-led roadmap, evolution, I would say. That certainly wasn't something we were planning in the early days. I don't know if you agree with that, Martin, or if you have other ones.
Yeah, I know. I think pretty much every use case that we run into over the years was a bit of a surprise. Starting with the one I described earlier of someone running SQL analytics over a custom data store, in-memory live data store. Then there was another big one where we built a analytics backend for a user-facing advertiser analytics at Facebook. So this was Presto running behind a UI where queries had to come back in the order of half a second to 4 seconds, and it had to be running 24/7 with geographic redundancy and so on, which is not something we had done or intended to do at the time when we started working on Presto. And then similar story at Facebook when people started seeing Presto or using Presto, they say, well, this is a lot faster than Hive, and if I'm going to be running queries to prototype my data pipelines, and then I have to translate that to Hive, that's going to be painful. So I might as well just run them inside Presto. And it's fast enough. It seems to work. So people start organically creating a bunch of data pipelines in Presto, and it eventually led to having a first-class project where we said, okay, we're going to migrate out of Hive into Presto. And then by the time we ended up leaving Facebook in 2018, more than 50% of all the ETL batch transformation workloads were running on Presto, and 85% of all the new workloads were being created on Presto. So, and you were asking about number of machines. It was running on tens of thousands of machines at the time. Yes.
Wow. That is fascinating that typically, people have an idea, a brilliant idea, they build a product, then the next challenge is to scale it, then the next challenge is to automate and reduce the cost. But your journey is reverse. And like you said, so which is very interesting that you already started from a highly scalable product, then you had to take it to the next level, of course. And talking about next level, another use case I see quite a bit these days is data sharing, marketplaces, data exchanges. Are you seeing those use cases?
Yeah. So with our kind of version of data products, which again allows you to create, for database folks who may be listening to this, they're essentially views. They can either be live views or materialized views that are served up as this data product, including that business context for consumption. And what we've seen is actually some of our customers, maybe this is also customer led in a way, using those and sharing those externally and monetizing data through that process. Snowflake obviously does something like this, but I think the key distinction here is that Snowflake only allows you to share data with other Snowflake database systems. And so it's kind of a proprietary network. Both the buyer and the seller, if you will, have to have Snowflake to actually make that transaction work. And by contrast, of course, Corridor Identity is being agnostic to data sources. So you can really serve up anything across multiple data sources and make that available for consumption. So it's an area that some of our customers are doing already. And it's an area that I think we'll be investing more from a roadmap perspective to just, really solidify that.
Thank you for sharing that. I tend to not ask roadmap related questions offhand because then, but thank you for sharing that. This has been so much fun just talking between the three of us. I'm amazed our hour is almost coming to an end. So I want to start wrapping it up. Martin, I want to ask you a question. Tell us something interesting that you do in your spare time, if you have any. And please share.
I have lots of things. One of my favorites is I've been a private pilot for 20 years now. And I've been flying on and off. But lately, over the past 5 or 6 years, one of the things I've been doing that is a lot of fun is doing formation flying. Mm-hmm. So we have a group of pilots here in California that we get together a few times a year. We go on practice formation flights, and then sometimes we organize for say 4th of July, we do a massive formation flight with 15 to 20 airplanes, and we fly all over here in the Bay Area. So it's a lot of fun.
What kind of plane do you fly?
It's a 6-seat Bonanza, an A36.
Okay. Well,
like
I don't know very much.
Small propeller-based plane. Yeah.
And I've heard somebody told me you're planning to do some interviews. like some technical interviews from your plane.
Yeah,
I'm
you want to
on
make
West
a,
Coast.
talking about that.
yeah, you should plug your future podcast, Martin.
Yeah, absolutely. Plane-cast. Now people can guess who I'm talking about. So I'm going to move over to you, Justin. I'm curious how this journey has been for you. What lessons have you learned that you could share with the audience and end with something, a fun fact about you?
Well, the journey's been incredible. I mean, I guess I've been doing this in some fashion or another, between my first startup and Teradata and this startup, for 13 years now, I guess. And, always learning for anyone in the audience that's thinking about being an entrepreneur. I think you have to have a commitment to consistently iterating and learning and improving and upping your game, because the job changes. I remember asking a very accomplished public company CEO early in my journey, does this job get easier? And he said, no, it's just different kinds of hard. And that stuck with me because I think that is so true. It is just new challenges and different challenges as you grow and scale. So that's been incredibly rewarding. I'm not nearly as interesting as Martin, so this is tough. He has much cooler hobbies than me. I'm at a stage in my life where I have very young kids, and that is where I spend my free time. So I feel like I know more about tractors than I should, because my son's very obsessed, and I feel like I have a good general survey of farming equipment, if anybody wants to know. I don't know if that's valuable, but that's the extent of my hobbies today.
Great. Well, thank you so much. By the way, when you were saying things never get easier, it reminded me of kids. You have very young kids, and I thought when the kids grow up, then your problems are solved, and only now I'm finding out it never ends. So yeah.
There you go. I think there are a lot of parallels actually between company building and raising kids. So
Yes.
it works.
Great. Well, thank you so much. It was such a pleasure. And thank you for joining this podcast.
Likewise.
Thanks for
Thank
having
you.
us.